Okay, in the next three problems, we want to find the derivative of a function composition at a particular point, and we'll use a slightly different strategy when we're trying to find it at a point. We won't need to do as much simplification. After we find the derivative, we'll just start plugging in. So let's see how this goes. For number 67, s prime of t, assuming that we rewrote s of t as t squared plus 6t minus 2 to the 1/2, the derivative will be 1/2 times t squared plus 6t minus 2 to the negative 1/2, then times the derivative of the inside, which would be 2t plus 6. And we simply want to evaluate this at the point where x is equal to 3, or t is equal to 3. So without doing any more simplification, we can go ahead and start plugging in. So when t is equal to 3, t squared is 9, 6t will be 18, so that's 27 minus 2 is 25. To the negative 1/2 means 1 over the square root of 25, which will be 1/5. But we'll go ahead and plug in t equals 3 into 2 times 3 would be 6 plus 6 is 12. So this works out to be 12 over 2 times the square root of 5, and so, or 6 over 5. For number 68, we're also going to rewrite that as 3x to the third plus 4x to the 1/5 power this time. And so for 68, y prime will equal 1/5 times 3x cubed plus 4x to the negative 4/5 power. Then we need to multiply by the derivative of the inside, which will be 9x squared plus 4. And we're ready to find this derivative when x is equal to 2. So we say y prime of 2 will be equal to 1/5. Then 2 cubed is 8, 3 times 8 is 24, plus 4 times 2 is 8, so that'll be 32 to the negative 4/5 power. And then plugging in 2 squared is 4, 9 times 4 is 36, plus 4 is 40. Now to the negative 4/5 power means 1 over 32 to the 4/5. But first I can divide 40 by 5 gives me an 8 in the numerator, and then 32 to the 4/5 power in the denominator. Now for 4/5 power, we can first take the root and then raise it to the power. You don't want to raise 32 to the 4th power and then try to find the 5th root of that. But we do know that the 5th root of 32 is just 2, and 2 to the 4th power is just 16, so that makes it much easier. So that gives 8 over 16, or 1/2. And that would be the derivative of y when x is equal to 2, y is equal to 2. We'll go on to number 69. A 69 can also be rewritten as 5 times the quantity x cubed minus 2 to the negative 1st power. And so f prime of x would be negative 5, x to the 3rd power minus 2, reduce the exponent by 1 to the negative 2nd power, and then multiply by the derivative of the inside function, 3x squared. And we're ready now then to plug in, or to find the derivative when x is equal to negative 2. f prime of negative 2, we have negative 5, then times negative 2 to the 3rd power is negative 8, and negative 8 minus 2 is negative 10, and that'll be raised to the negative 2nd power. And then 3 times negative 2 squared would be 3 times 4, or 12. Now because we have negative 10 to the negative 2nd power, we'll put that in the denominator, and that'll come out to be 100, and 5 times 12 is 60, or negative 3/5. And I'll just briefly use the graphing calculator to verify this last one. So I enter the function 5 over x cubed minus 2. I go ahead and graph that, and now I'm looking for the derivative when x is negative 2. So I have second, calc, option 6 for derivative. I put in my x equals 2, and I get negative 4/3 there, but actually I'm not looking for that. I'm looking for negative 2. So second, trace, 6, negative 2, and there it is. 0.6, negative 0.6, or negative 3/5. That does it.